Okay.
So this is then the first lab about the timer and counter. We start by creating the project. Then we insert our PLC station, do the hardware configurations, insert our rack. Then we place our CPU for the simulations. Then we go on our program, open the OB1. So there are 3 timers we're going to look at. So I'm placing each in a new network. We need to give each timer a variable to store data, so T1, T3 in this case. For better control, we use memory bits as input. And for the outputs, we use the output byte 0. So on the input TV, we put our time data in this format. So somehow I can't place the hashtag, so I'm going to use the on-screen keyboard for this. So now we set the timer with 10 seconds. Just use the same value for the other timers as well. And for the reset, we use first memory bit. So these both outputs, BI and BCD, just give us the remaining time. So I'm going to use here in memory word. Okay, that's it so far about the timer. So now we go and test it. We open the PLC. We download our file. Okay. So now as we put all of our memory bits and the outputs we need in our PLC, we can start the simulation. So So now we can activate the first timer, which is an on-delay timer. So as soon as we activate it, the remaining time starts running, and as soon as the 10 seconds finished, our output gets set. If I'm restarting the timer while the timer is still running, just like as soon as I set the memory bit 0 on the value 0, the timer just stops, and as soon as I restart the timer, our remaining time starts at the 10 seconds again. And the remaining value we can watch here in the memory word 10. So if I'm going to change this to the memory word 11 for the second timer, and we activate this timer, this is off timer, so as soon as we set the memory bit, our output is set as well. As soon as we set our memory bit at 0, the time is running, and 10 seconds later, the output gets the value 0 as well. That's the same as with the other timer, what means like we can restart it. This timer is just reacting on the negative edge of our input signal, and as soon as we put in positive edge it stops, and as soon as we set our memory bit on 0 again, we have the 10 seconds count on again. So about the last timer, our last timer is reacting about impulse. So as soon as we give a positive pulse in there, the timer starts running, and 10 seconds later the output will be set. And there's no difference if I'm setting the value on 0 after it got 1 first, the timer is still working. The timer is just changing when I reset the timer first. And then I can restart my timer, and as soon as there's another positive edge, we restart at 10 seconds and the countdown is straight running. Yeah, so our output is set again. If we go for the memory bit 12, should be able to watch. So here we can see the remaining value counting slowly down. Okay, that's it so far to the timers. Now we're going for the counter. So for that I'm placing 3 new networks. So we have our SCU, this is our counter, our upper counter, our down counter, and COD is a mix between both, where we can use the up count and the down count function as well. Inputs. So we're using the third bit of our first memory byte. So here we have to give the value for the storage part as well, so in this case counter 1, counter 2, and counter 3. So here at our CU input we have our so our counter for up, our counter input for down. So for that we just use the 0, 6. Then we have our set value. With that value we can set our counting range to the output. So in this case we're going to use a memory bit for this as well. Yeah, we need to format 16 hashtag. Wait. So we have to put our value in there with the format C hashtag and then our number we want to count to. And we have our reset pin. Just change the set value that it's a bit more sensible. So on the output we just put the memory word for our address. So this one is both the same, so this output just shows us the current counting value, just in a different format, so it's actually not really important which one we're going to use. And that's it so far. Closing this and transfer the code again to the PLC. Okay, so now when we turn the PLC on, and just add the memory bits I've used. Okay, so with 0.3 we can activate the up counting. So our value changed from 0 to 1 to 3, and if we're going for the CD pin, then we count down to 1 and back to 0. our output is not set anymore, our output is just set if our counting output is higher than 0. Now we have our value at 1, and if I'm pressing now or if I'm activating now the set pin, then our output increases about 5, because 5 is our counting value here. And yeah, you can count up and count down until you're done with this block, and then you can reset it over the memory bit 0, and our output gets 0, and also our counting output gets 0 again. And so our counter, which is just counting up. So here we can use this bit. We see our value increases. And if I'm pressing now the set value, so if I'm pressing now the set value, then our output gets set to our previous defined counting limit. And then you can reset the block the same way as the other one. Just put a reset pin high, the output is 0, and also the counting output gets 0 as well. And principally it's the same with the down counter. So I put 5. First we have to set our value to 5, and then we can start counting down. Decreases until we have 0, and then the output gets reset as well. And otherwise, if you want to, as example, reset already after 2, then you just use the reset pin. In this case, this memory bit, and our output and our counting value gets 0 again. And that's it basically to the first lab report. You just have to follow the exercises.